So after the run has finished, we can see that the check study status component says completed. Right now I have the run here because I have the study connected to the check study status. But in case you don't have this connected, you can get the run by right-clicking on the check study status component and browse Cloud Study from Pollination Server. And if you browse to the right project, you can get the select the run from the pollination jobs, and you should get it here. So this run we have here is the same as this one. So in order to get the results and visualize them in Grasshopper, we need the check run results component. This will give us all the outputs. So in this example, I'll show how to visualize the results and in Grasshopper. And another way you can do it is to use a pollination app for LEED tailored option 2. And there will be a separate video for this app, which you can also watch. So to get these results, right now they are not downloaded. We need the load assets component, and if we just connect the credits to the assets, we get the credits here. And if we read that in a panel, we can see the results. This is the credits is the overall summary of the whole project or the whole model, where you can see the number of LEED credits, which is 3, and maybe the second most important thing is the percentage floor area passing, which is 93. So in order to visualize the Illuminance results, in this example I'll just show the one for 3 p.m. I simply just connect the output here to the assets, and users who are familiar with running studies in Grasshopper, either pollination studies or local ladybug tools studies, probably know how to visualize this. And you do this by going to the ladybug tab, and select the spatial heat map. And what we want here is the mesh. This is the mesh from the grid creation. But what we need to do first is to join the meshes by the native mesh join component. And if we connect this to the spatial heat map component and then the Illuminance values, and then flatten the values because the mesh is joined, and then add a legend, and let's set it to 300 minimum and 3000 maximum. We can see this visualization, and I will just disable this component to give a clearer visualization. So here we have the Illuminance for one of the time steps, and then we can also show this. We have these passing outputs for each time step, and then a combined one. And the combined one is the important one, since it's this is the one that the percentage passing floor area is calculated on. So if we download this output, and just quickly see what the output looks like, we can see that it's basically just a list of ones, and somewhere there should be some zeros as well here. So the zeros are the sensor points that failed, and the ones are the sensor points that passed. And this means that the sensor points that passed are the sensor points where the illuminance values are above 300 lux, in case you have this glare control set to true, and if it's set to false, then it's the sensor points where the illuminance values are between 300 and 3000 lux. So in order to visualize this, I will copy the mesh, the spatial heat map, and here we want I will connect the values as well, and here we want a different type of legends. I want the legend parameters categorized. So in the domain, since the values are 1 or sorry, either 0 or 1, I will just connect a single value, 0.5, to divide the values, the domain, in either lower than or higher than 0.5. And in the colors, I want just 2 colors, and I will just select the color swatch. And for the failed sensor points, I want a let's take a very bright red, and for the green, I want simply a green color. And now I want to add some categories, which is a panel, also a list of strings. I use the panel component to create these, and I will simply type fail and pass. And if we connect the categories, we should get the visualization as I wanted, where all the green area is the passing sensor points, and the red is the failed sensor points. And then we have the space summary. This output is a summary for each space individually, and it's a CSV file. And one way to show this in Grasshopper is by the read file native component, and then connect a panel to the output. Here you can see space by space what is the sensor count, the area, the percentage passing for each time step, and the combined passing percentage. So this is a short example on how to visualize the Grasshopper. As mentioned, there is a separate video for visualization in a pollination app.